Interpolation is fairly easy math-wise. You're using a basic formula, so it's the target minus the lower bound, which I'll write that as LB, over the upper bound. I'll write that as UB minus the lower bound. And then you're setting that as an equality to the same thing over here. How do we apply this in Stellar Explorers to round 3 and beyond? Well, in your launch vehicle performance charts, you're given inclination and altitude values, and those correspond to spacecraft mass. But sometimes you want a different inclination or a different altitude, and you use the same equation. You have these values for the target, your lower bound over your upper bound minus your lower bound, and the same thing over here. Okay, so here is an example of a launch vehicle performance chart. Now, let's say you want to find the maximum mass of your spacecraft, given that you have an inclination of 40 degrees and an altitude of 2,000 kilometers. So you have values for 40 degrees here in this green column, but we don't have a value for 2,000 kilometers. So we have to use interpolation. Here's your lower bound, here's your upper bound. So the two numbers that we're interested in are here and here, and then there's another set of numbers that we're interested in, here and here. So let's go ahead and do this calculation. So in setting up our equation, we know our target value for altitude. Altitude's on this side. We have 2,000. This is in kilometers. Minus 1,800 over 2,200 minus 1,800 equals, and then we want to look for the mass. This is in kilograms. So we have our maximum mass is x minus our lower bound, which is 5,442, over our upper bound, minus our lower bound. And then using algebra, you rearrange this equation, and you end up with a value x equals 5,387.5, which means that your maximum mass is 5,387.5 kilograms for an orbit with 40 degrees inclination and 2,000 kilometers in altitude. So you can use interpolation as well to find the maximum mass given that you want to change the inclination. So now let's say that you want a 42 degree inclination and a 2,200 kilometer altitude. So that means that we're paying attention to this blue row here. So 42 is in between 40 and 50. So this is our lower bound, and this is our upper bound. And the two sets of numbers we're going to be interested in are 40 and 50, and then this number and this number. So let's go ahead and set up our equation. And then if you work out the algebra here, that's going to give you a mass of 4,899.4 kilograms. So what if you want to change both the inclination and the altitude? Well, I'll leave the answer below, but try to go ahead and find the maximum mass for 42 degree inclination and 200 kilometers in altitude on your own using interpolation.